I want to talk to you more about the mechanical advantage. I want to focus on how to solve some of these mechanical advantage problems. Now, I have here a sample from the worksheet you'll be doing in class. The question reads, a claw hammer has a mechanical advantage of 20. It is used to pull a nail that exerts a resistance force of 3,500 newtons. What effort force is needed to pull the nail? Now, when you read a lot of words, it's intimidating, and you need to get out of the words and get into the math. So I have some steps here that will help you do that. The first step is to identify the knowns. So I have used that same color marker to come up here and underline the things that I know. I know I have this mechanical advantage of 20. I know that I have a resistance force of 3,500 newtons. Now, my second step is to decide what those knowns are measuring. What does newtons measure? Newtons measures force. Which force is it? Well, when I read the problem, it tells me clearly it is the resistance force. So I label that as FR. This 20 doesn't have a unit. That tells me immediately that it's a ratio or a multiplier. And I know that mechanical advantage is a multiplier. And I see that it is labeled as the mechanical advantage in the problem. Now I have an idea of what formula I need to use. This MA equals FR over FE has those two pieces, FR and MA, in it. So what effort force is the question they're asking me? I underlined that, and that's also in my formula. Now that I have successfully identified my knowns and labeled my knowns, I can go and check the units for the things that I have. And in this case, I only have one thing with a unit, which is okay because the mechanical advantage is a multiplier. I want my answer to also have newtons. Now, step 4 is to substitute and solve. So I use my equation. Depending on your comfort level with math, you can either rearrange and solve like I've done here, take the FE and multiply it to the other side, and then divide the MA out so that you're solving for the FE. If this is intimidating to you, then remember that we have the triangle that will allow you to take this term that has the two dividing each other and put them above and below. The FR's on top, the FE's on bottom, and the MA goes in the space that's left over. Either way, you're going to come out with the answer of 175 newtons because 3,500 newtons divided by 20 will give you the 175. Don't forget to put the newtons for your unit to get full credit on your problems. Now, that first example had newtons in it. And notice I didn't even stop to think about what type of machine it was. I wasn't worried about, drawing a picture or labeling a diagram because all machines will treat newtons the same way. It's always the resistance force divided by the effort force. And as long as that information is given to you, that's the easiest way to calculate the mechanical advantage of a machine. But sometimes the problems will give you distances. They'll give you the lengths of the different parts that the machine and you are doing. And you have to decide which part is yours and which part is the machine's. Now, let's look at an example of that. This problem says an oar is used to row a boat. It has a handle length of 55 centimeters and a blade length of 220 centimeters from the fulcrum. Find the mechanical advantage. Now, that word fulcrum should clue you in immediately into the fact that we're talking about a lever. Now, even if it doesn't, it's okay because our first step will get you there. On step 1, it says identify the knowns. I come up here and I underline the values that I know, the numerical values. Notice I always include the unit when I underline. So I have 55 centimeters and I have 220 centimeters. But I also need to, whenever I see distance on a machine problem, I need to include as a part of this step drawing a little picture. I know you're not all artists. I'm not either. But if I can draw a boat with an oar sticking out of it, so can you. Now, we're going to draw this canoe, and I drew an oar labeled with the 55 on the handle and the 220 from the blade to the fulcrum. Where's the fulcrum on an oar? Well, it's right there where the oar rests on the edge of the boat. That's where it will rotate as I row my boat to shore. Now, labeled the gnomes is the second step, just like it was in the first problem. So 55 centimeters from the handle. Here's the beauty of the picture. That helps me get an idea of what that 55 is measuring. Is that me or is it the boat? Well, where do I sit? Don't I sit in the boat? And if I do, then won't I be touching the handle part of the oar? So that 55 centimeters is me. That's where I'm going to do my work. And then what the oar is going to do for me is the 220 centimeters. So the 55 is the DE and the 220 is the DR. Okay? Now, step 3 is to check my units. Very important when you're looking at two different distance values to make sure that they're both in the same terms. If I had had one of these measured in meters and the other in centimeters, it would be very important for me to change those to make them match. But in this case, we have both of them in centimeters, so we're okay. In step 4, we're going to substitute and solve. Now, this equation is a little different from the one that we had in the last problem because we have DE over DR. The reason we use that formula is because we are dealing with distances. Please notice also that the E is on top in this problem. In the other formula with the forces, resistance was on top. So be careful to make sure you place your values in the proper location in the formula. So DE divided by DR would be 55 divided by 220. The centimeters will cancel out, leaving me with that ratio that the mechanical advantage should be. This is probably one of the few times you'll hear me say you don't have to have a unit for your answer. So 55 divided by 220 gives us a mechanical advantage of 0.25. Well, some of you will be tempted to switch those numbers around to try to get a large number. You're used to dividing the larger number by the smaller number, but it's okay to have a mechanical advantage of less than 1. Don't switch those numbers around to get something that's more pleasing or feels more right to you. This 0.25 tells me that I'm having to work 4 times harder to do the job of rowing this boat than it would take me to just swim in the water. Okay? This 0.25 tells me that the machine is making the job safer, not easier. Okay? Remember, for those of you that struggle with the rearranging of the formulas, that you may also use the triangle. So I put the 55 at the top for the DE and the 220s at the bottom for the DR. When I divide those out, I will get to the same answer as I did here. Okay?